conservation. The magnitude of properties within a chemical system such as mass, energy, or charge remain unchanged during a chemical reaction. These properties may be exchanged.
Law of definite proportions. The proportion of element in any compound is always the same.
Law of multiple proportion. If two elements combine to form different compounds, the ratio of masses of the second element that reach with a fixed mass of the first element will be a simple whole number ratio. Let us demonstrate the law of multiple proportions with these two elements, nitrogen monoxide and nitrogen dioxide. Nitrogen monoxide is made up of nitrogen, N, atom, and one oxygen, or O. Atoms forming NO and nitrogen dioxide is made of one nitrogen, or N, atom, and two oxygen atoms forming NO2, which is how the elements nitrogen and oxygen appear on the periodic table, and encircled in red are their atomic masses. This is the example of nitrogen monoxide and nitrogen dioxide. Nitrogen monoxide nitrogen monoxide has one oxygen and one nitrogen. Nitrogen dioxide has two oxygen and one nitrogen. If we run off the atomic masses, this is the atomic masses. If we run off the atomic masses, nitrogen has an atomic mass of 14 and oxygen has an atomic masses of 16. So for nitrogen monoxide, we can say that it is made of 14 parts by mass nitrogen and 16 by mass oxygen. This ratio of nitrogen. So for nitrogen monoxide, we can say that it is made of 14 parts by mass nitrogen and 16 parts by mass oxygen. This ratio of nitrogen to oxygen is therefore 14.16. For nitrogen dioxide, we can say it's made of 14 parts by mass nitrogen and 32 parts by mass oxygen. The ratio of nitrogen to oxygen is therefore 14:32. Let us summarize this information in this table. This is the table of nitrogen monoxide. As what I have said earlier, nitrogen has 14 atomic masses and oxygen has 16 atomic masses. 14 divide 14 is equals to 1, and 16 divided by 14 is 1.143. So we can read this by 1:1.143 gram per mole.
Example of the law of definite proportion. Let us take for example the compound water. Whatever the source of water, its composition is that of 2 atoms of hydrogen and 1 atoms of oxygen. Example, the faucet and the container. And there's 1 oxygen bonded by 2 hydrogen. This figure shows that water from any source is always made up of 2 atoms of hydrogen and 1 atom of oxygen. If we calculate the molecular weight of water, we come up with 18 gram per mole. In 1 mole of water, there are 2 grams of hydrogen. 2 grams of hydrogen and 16 grams of oxygen. By weight, we have a percentage of 11% hydrogen and 89% of oxygen. In 1 mole of water, this translates into a ratio of 1/8 of hydrogen to.
This is the balancing equation of conservation of mass. Carbon, we have 3 carbon and 8 hydrogen, and I put a 5 this to make it 10 so that to the other side can make it balance. You need to times this 5 times 2 equals 10. On the other side, the chemical reaction may be changed, but they are the same numbers of chemical. We have 4 times 2 equals to 8 hydrogen, and this we have 6 oxygen. In this oxygen, this part, we have consider this yeah, 6 equals to 10 because we have 4 oxygen already is there. As we can see, the equation is already balanced because we have 3 carbon in this part and we have 3 carbon in this part and 8 hydrogen in this part and 8 hydrogen in this part and 3 carbon in this part and 3 carbon in this part.